They do.
What else? What other options do we
They
have?
have a lot of mentions.
Okay, guys. So Chris couldn't come today because he was sick, so I'm gonna replace him. Uh, it's gonna be amazing. Now, if I get this to work, there you go. Okay, we're gonna take attendance first. So Matthew, where are you? Okay, wait. Let's do something faster. 2, 4, 6, 8, 10, 12, 14, 16, 18. Damn, someone is missing.
All right, so let's do the other.
Yeah. Can you figure who is missing?
Wait, raise your hand if you're not here.
Zach. Okay, everybody is in accordance that Zach is not here.
Wait, yeah.
Okay, cool. We just need one that takes the blame.
Yeah, did anybody like walk past the lounge lately? Because like last week I had to wake them up to bring them down here.
Okay, cool.
Like, show them the lounge.
So we're done with that. Good job. uh, we're gonna talk about C programming, one of my favorite languages. So why are we gonna talk about C programming? It's just because it's required, and most of the assembly code and how you unpack things and stuff. It's basically on C, regardless of the language. Like Java compiles in C, Python compiles in C. Everything at the end of the day uses some C library. MATLAB uses C libraries. Everyone, almost everything uses C libraries. Even like the new languages that use their own language, like Go, for example. At the beginning, it was using C libraries. So it's pretty interesting, but basically C has become the main language to do everything. So who of you knows anything about C or C++? Raise your hand. Okay, so it's a few of you. I'm gonna narrow it down. Who knows about C instead of C++? Okay, cool. Who can tell me the difference between C++ and C? Extra points. Sure.
C++ has more options than C.
Okay,
Isn't,
cool.
Actually, isn't C++ object oriented? Like
Yeah.
C isn't.
C++ has class.
Yeah, correct. Give it to me in one word. What's the difference? No, you have to create two
Classes.
Yes, but the word I was looking for, yeah, it has classes, object oriented. It has already defined structure that you can use. Mainly, it's a superset. Okay, cool. It's a superset, so you can take that as notes. Superset defined is like basically C with steroids, right? So that means that it has all the functionality that you can do in C, plus you say you can create classes, you have structures that have been predefined for you, so you don't have to code everything by your own. That's the problem about C, that it's an amazing language that you can create basically anything you want, but you pretty much have to create it from scratch, right? There's like mostly just basic libraries that you can use to communicate with like the hardware, but you don't have high level stuff that you can use like Python. You just import the library and it does everything for you, right? Cool. So we're gonna look at arrays. Have you ever seen arrays? Cool. Yeah, amazing. So arrays in C or C++ are defined like this. You just put the size of it and you define it. Have any of you allocated arrays before? Like not create them statically, but dynamically? No? Yes? Maybe? Raise your hands. Okay, cool. We're gonna do that later. I can show you how to do it. It's pretty cool, actually. And then with allocation, someone talk about memory management. In C and C++, you have to handle your own memory. So if you allocate memory, you have to deallocate later. Otherwise, your program is just gonna get a lot of memory, and if you keep running, it's just gonna get memory hungry, and it's gonna use all your resources of your computer. Okay. Now, let's see. Who can tell me what this code is doing? I have not seen it, so we'll see. Anyone wants to know what this code is doing? Yes.
It's just creating another array local and just copying like global into it.
Yeah, that is correct. What's going to be the final values in local I? We have, so who can tell me what's going to be the final value? Yes.
The local values are for I are going to be 0, 1, 2, 3, and 4.
Okay, and for global?
The global values are then going to be set to 0, 1, 2, 3, and 4.
Correct. So that initialization didn't work for anything because we're not using it here. We're just taking I from 0 to 1 less than 5, so it's from 0 to 4, and then putting them in this local, in local and global, which this array has been created and initialized. So when you create an array, when you put that 5, you're allocating that memory, right? And you do it statically because this is a value, it's static. And then here you're creating an array. Yes.
Would that error out because local actually has no values in it?
No, it won't. That's what I'm going to say. So when you create local 5, you're actually creating the array, allocating the memory for it, but all your memory is empty. So what values can in that array happen? So it can be anything, right? Basically what you're doing when you do this, my God, anyone has a marker
There should be a marker on the podium somewhere.
on the podium?
Or usually they keep it randomly placed.
Isn't there a box marker for the telephone?
Yeah. Good catch. Amazing catch. Cool. So basically, here you're saying, I'm going to create global, right? And then I'm saying 5, right? If we just do this, then what this looks in memory is just saying, hey, I'm going to have this guy called global, right? It is going to point, and I'm going to explain later what's going to and stuff. So 5 elements of int. So these are usually 32 bits, or it can be 64, right? 5 of them, 1, 2, 3, 4, 5. So that's this first thing, right? That it's saying right here. And then this is saying, well, now that I have created that, I'm going to put those values here, right? So 123, 87, 487, 7, and 978, right? In the other one, when you say local, so when you create and you don't put anything there, you're just saying local. So yeah, there's markers, but they're all dry. Anyway, it's saying I'm gonna create it. I'm gonna leave 5 spaces for it, but I'm just gonna leave them empty. So it's not gonna create an error. You're just gonna leave it empty, and then you are what we call initializing it later on once you do local I equals to I. But here, when you allocate memory in these things, it can be anything. You know, it's just we call it garbage. It can be a -1, a 57, whatever. You know, it could be anything. Literally anything that was in memory before. It could be anything. So it literally is a random value of zeros and ones that the memory had previously there. You know. Usually, I don't do this. I usually initialize, if I create a static array, I initialize it. There's ways to initialize everything by 0, but you just say equal, and then you put brackets and just say 0, and it initializes everything to 0. Cool. So now we're going to see structures. Has anyone used structures in C or C++ before? Yes?
Yeah.
Can you tell me what's a structure?
So a structure is basically it allows you to combine multiple types of values into one data type, into like your own data type.
Correct. So you said one important word right here. I want you to tell me what it is. What's a type? In C?
Well, in C, you have to define the type of each variable. So integer, character, they don't have strings, array.
Well, array is not a type. Array is a structure. So you just something, data type. You name data types, right? You haven't defined what's a data type right now. So a data type is just an element, right? That stores certain type of data. Element stores certain certain type of data, right? And then in C we have something called primitive data type, right? So it's called primitive, right? And it's what you were talking about. It's gonna do DT, right? DTs are int, right, float, double, char. You also have byte. Nobody uses that too much. You have byte there. And that's it. You actually in C you don't have booleans or anything like that. In C++ you do have a boolean, right? And maybe we can create a structure called boolean and see how we're gonna make it. But yeah, you have boolean in C++. So this is for C++, right? C doesn't even have booleans, right? Am I missing something? Int, float, double, character, byte. Do you know what's a float and what's the difference between a float and double? Anyone can tell me what's the difference between a float? Yes.
Isn't like a float is more specific than a double? Like it goes more like decimal places than.
Not really. Float is just a point in decimal place, so it's like 1.5, right? And a float, depending on the architecture, if you're using a 32-byte architecture, it's a 32, right? And a double is just double, so this is 32 bits, right? This will be 64 bits, right? So it just allows you to put more values into it, so it's a bigger element. It's still mounting to the same, so float and double is not that it's more precise. It's the same precise, but you can put more values in here, right? This goes, is as many, for example, an int here, you can put an integer as big as 2 to the 32 minus 1, right? I think so, yeah. So that is how big it can go. 64, you just do that. For an integer of 64, you will do 264. Is that correct? Yeah, something like that. So yeah, this just allows you to put bigger values, right? And you can do the same for int by using a word called long. So long int allows you to transfer, if you have an architecture of 32, it allows you to make, if you do long int, it allows you to allocate 64 bits, right? And if you do long, it will be 128, blah, blah, right? But there's just certain threshold that you can achieve based on the architecture. And if you have a 64-bit architecture, right? What will be the double of it? Correct. So yeah, that's the difference, and those are the primitives. Now you know everything about data types in C. What's a structure? So a structure is just a combination of primitive data types, right? And what else? Another structure, right? You can put a structure inside a structure, right? So it allows you to do things like, let's see this. We have my structure, which is an integer, character, and a double, right? So we're just putting 3 primitive data types right there. One of them is an array of integers, so it's not 1, but it's 5 of them. And then here we are, so when you create here we're not creating a structure, we're just defining, it's like a blueprint, right? We're saying, this is how my structure is gonna look like. And then once we create one, they were creating one of those structures called JMS. And then we're creating a function called void that is passing a structure, which is my structure, and it's a pointer. So when we create structures, why do we think we use pointers? You could still create a structure without the pointers. But it's just the same way arrays work. Like, it's better to, and structure is the same thing as an array would look like, but instead of allocating like just, here we allocate 5 elements of memory, right? You're allocating 5 elements of memory plus a character, right? So with that one element, plus a double, which would be 2 elements, right, of memory. So that's what if we take this out, that's what it will look like a structure, right? So we just have a name called JMS that is pointing to that structure, right? Which has this, and this. And by just doing dot blah, we can access. In this case, because it's a pointer, instead of the dot that we use in Java or other places, we use this, which this arrow means when you have a pointer and you wanna get the value of your data structure, you point it to the y. If you initialize your structure without the pointer, it will be just q dot y equals to blah, right? And then once we create it here, that's when we're actually allocating it, right? Here we're just defining it, and then here we allocate everything and create the data. It's not initialized, here we're initializing. And what is q? Well, q is just saying I have my array x, and I'm gonna put from 0 to 4, right? That's pretty much it. And then here's another way to allocate. You see this one is not a pointer anymore. You're just saying, I want to allocate. This is malloc. It's a function that gives you memory. I want to allocate the size of this structure. So basically, the size of this structure will be 5 integers, right? 1 character, and a double. A double is equivalent to 2 integers, right? Because it's a double. It's still the same thing. It will be 32-bit architecture. It will be 32, and then this will be 32, right? Size of 32 bits. This will be 32 and 32, right? Here is my double, right? Here is my double C, right? This will be Y, and this is X. Forget about that thing, that's my lab partners. Okay, cool. That's pretty much it. We're saying allocate that type of memory, and then here we're just casting. Everybody knows what's casting? What's casting? Someone tell me. You're combing your hair, but you can tell me what's casting. Tell me what's casting.
When you put a thing in a thing.
Okay, cool. Yes,
Convert one data type into another.
correct. So here we're just getting a pointer to memory that has, it's called void, right? It's just a pointer to memory. We don't know what it is, right? When we cast it, we're saying, okay, that pointer that you're giving me, I want you to cast it to a struct. You tell me all that memory that I allocated, I want it to look like this. Then I'm going to do that. And then I'm just going to send test GMS, put it here. And after GMS, because it's passed by reference, right? Because it's a pointer, right? It's passed by reference. Then all those values get updated there. Cool. Now we have a linked. Interesting. This is actually very cool. And it's, honestly, when I code in C, this is the structure that I use the most. Because it's actually the easiest structure to create. And that's pretty much it. If you're trying to create a dictionary, aka hash map, in C from scratch, you need a hash function and a lot of other stuff that you don't have. So it's, honestly, this is the only thing that I use. I've created networks in C and stuff. Linked lists are really good. If you create a big project, you know, a whole system or whatever, then you have to create your own data structure, right? Which is not only a struct. It's a struct that has some functions that you can use to work your way around that memory, right? So someone can tell me what's this type defined struct node pnode doing? Anyone? Yes.
It's defining a new data type that's called pnode, and it's based off of the structure node.
Not really, but almost. So it's not defining it in the sense that, like, we're defining a structure here. It's just telling I have a structure called node, and I want to call it pnode now, right? Because when you have a structure, right? If you wanna, I have my definition of structure, and then usually I have a name that goes here, right? So this is my name. Or you can take the brackets out and you put the name at the end, name here, and you can use it once, right? So usually, to use it several times, they put the node here. But if you want to create a node, like a structure of type node, you have to say struct, right? Node, and then you have to give it their name, right? In order for you to not do that, type define is just a C type of thing that allows you to say, well, I want to put a nickname into my struct node, right? And that nickname is going to be pnode. That's literally what it's doing. So I'm saying I'm going to define pnode as my structure node. And that way, when you write and you create more structures of that, you don't have to do struct, space node, and then you have to your name, right? You just say, okay, I'm just gonna call p node from now on. And basically what the C compiler does and everything is like, okay, this guy defined this here. Now, whenever there's a p node, I'm just gonna replace it by struct node, right? That's what the compiler does. And it makes your code more readable, and you have to type less, which is very important. Cool. So now we're here creating two nodes, and we define it as pointers, so we create them. When you do this, that's kind of a big problem in the sense that, and I'm going to ask you this question. Hopefully, let's see how is your intuition. When I create this, is my memory allocated for that? When I say p node current and then head, yes.
Yes.
Are you sure? And what's happening here? No, it's okay. It's good to learn. That actually happens to me a lot. I forget that it's not like other languages like Java. Once you initialize a structure or a class, it allocates the memory for you. In C, everything is annoying. You have to allocate memory for everything. So if you point, yes.
Just a second. Or is it different in C++? Does C++ automatically allocate the memory?
No. So C++ and C are the same thing. That's why I started by saying it's a superset. So it's basically C with steroids, which means that you can do everything as you do in C, but you have additional functionality. That doesn't mean that it behaves different. So C and C++ behave exactly the same. The only thing that C++ allows you to do more stuff, but doesn't mean that you can not do the rules that C has. So in reality, it's just like C++. I usually don't like to use C++ too much because if I want to do like classes and object-oriented programming, then I go to a real object-oriented programming language like Java, like Swift, like C#, like Objective-C, right? C++ was a solution to put object-oriented programming and other types of libraries into C, right? But it was done a long time ago, and it's because there was no kind of other ways to solve the problem, right? Someone just said, okay, I'm going to do C++, create all this stuff real quick, and everybody problem gets solved. But nowadays we have other better tools. Anyway, so yeah, here you're just saying, I want to have two pointers that point to something that resembles a struct node, right? But memory hasn't been allocated, so you already create a pointer. Your pointer is just literally what a pointer is a whatever your architecture bit is. So if it's a 32-bit architecture computer, you say it here, and this is an address, right? And this address points to space in memory, right? But when you create, and that's what we're going to tell you, when you create this current head, you're actually not pointing yet. You're just saying create this address, right? Whatever is inside here, we don't know yet. It's garbage. As far as we know, it's garbage. For example, here, what's happening? Here it's saying, oh, by the way, my head is going to equal to null. So I define this, I create my address, and then null just means put a 0 here, right? That's what it's saying. That's good. You should always point your pointers to null if you're using them. Yes.
So then when you do the p-node start current and start head, then that is allocating memory, but it's allocating memory for the pointer.
So no. Pointer. Oh, when you do this, yeah, it's allocating memory for a pointer, but not for what you're supposed to be pointing to, right? So a pointer is just the size of an int, so it's 32 or 64 bit, and it holds an address inside, right? So if you set it to null, null is just the same as 0. You're saying, well, whatever my address is, set it to 0, right? But yes.
And is there a limit to how many pointers a program can store? Where are the pointers located? Is there a stack or heap somewhere?
Yeah. So usually, if you do this, this will be allocated in the stack. You can malloc a pointer, so you can make a pointer address of a pointer, which is kind of counterintuitive, but you could do it, right? You could say, hey, p-not current and then malloc size of a pointer, right? Which is basically what you're already doing this by default, so it's not need to do it. But yeah, and where they get stored? They get stored in the stack or the heap. Usually you don't dynamically allocate pointers because what you dynamically allocate is memory. So you have your addresses, and then based on whatever the user inputs, you allocate it to one type of memory or to a bigger set of memory, right? So these are your starting points, right? That's more of what we need to know. Anyway, so when we do current malloc size, what you're doing here is saying, well, give me an address in memory, right? So it's going to be address here that has this space, right? And that's going to go inside here, right? So this is my current. And now it's pointing to some memory, right? So that's what you're doing when you malloc here. Remember that we were talking about malloc just passes a pointer value, which is just an address. And they're saying that address I want you to construct it to a pre-node, right? Custom. Yes.
So for when you do head equals cur at the bottom of the for loop, are you assigning like the pointer value of cur to head, or what? Or are you pointing
so
them to
you're
each other?
assigning whatever is inside current, right?
Okay.
So let's assume for a second that here this address was F. Okay, let's call it that. That's the address that we have. Once we're in this line, this is current, and then we have FF, right? And in this same line, right now my head is gonna be 0, right? Because we set it to null before. Right here, my head is 0. In this part of the code, it's still 0, right? And then I do something current, and then head here equals to current. Just means now, in that line of code, I'm just gonna say FF, right? Do you all follow? Yes.
Why?
Why? Because you're assigning, so this is a pointer, right?
Yeah.
So it's just one memory that stores an address in memory. That's the definition of pointer.
But why are you assigning a pointer to another pointer when in the next line you literally just do the opposite? So it's just the same as if you just got rid of it and just had one pointer.
Let me see.
Because you do head equals cur, and in the next line you do cur equals head. So you just traded FF between two places.
Let me see what this code is trying to do as a whole. So you're saying my next, yeah. Okay, basically what you're doing here, the high level thing that you're doing is you're making a node, right, that has 0, point to 1, that points to 2, that points to 9. That's what you're doing. And your head is gonna end up being here. That's the code that is good.
Oh, so you're erasing down the list.
Yeah.
Okay.
It's kind of counterintuitive. Usually your head is in the top, but in this case it's like it's doing, what is it doing? What's this type of data structure? That the last incoming in is the first one in the head. Last in, first out. Is that A? Last in, first out. Who does that? A stack. There you go. So basically, you're defining a stack here. The way this behaves, it behaves as a stack, and the way it prints it as a stack, right? So it's gonna print 9, 8, 7, 6, 5, 4, blah blah. Cool. So everybody understands that. If not, just let me know. We'll go over it. This is confusing as hell. It took me years to understand, and even right now I don't understand that. Yeah.
So for that code, so
Oh, yeah.
for that code, so if you start, you set the current node to 0, then you set the current node. Well, I see. So for that linked list, you're the directions of the arrows, because the first node would point to null, the second node would point to the first node or to 0, and so on and so forth. Otherwise, you wouldn't be able to iterate through the list. So like head will be 9, and then you would look at the address and not in the 9th or 9 node to go to 8, and so on and so forth. Not the other way around. Because otherwise, you need the head to or the tail or whatever to point to 0, so that way you could go up through the list from 0 to 9. But you'd have to traverse it from 9 to 0.
Okay, you lost me right there. You wanna go over what the code is doing real quick?
Yeah.
Pretty cool. So at the beginning we have our current node. So current is pointing to here, right?
Yeah.
Cool. And then current next is gonna be head, right? So what he's doing right now, it's saying current, right? It's that, and my next one
No.
is gonna be equal
Head
to
is set to null. The first time it goes through the list, head is null.
yeah, you're correct. So it's pointing
No,
to something. Yeah.
it's pointing to 0. Like it's pointing to nothing.
Yeah, it's pointing to nothing. You're right.
So it's not pointing to node number 2 because we haven't created node number 2.
Yeah, but let's see what happens in the next one. So we're saying this, right? Current equals to 0, and it's pointing to head, which is null, right? And then head becomes current, right? So head is this guy, right? Let me see if, yeah, you might be right. Let's see. Okay, in the next one, we're creating a new current, right? So we have a new current node, it's 1, right? And we are pointing it to our head, right? So we're pointing it to here, right? Oh, you might be right. And then we're setting up our head to current. So our head, yeah, you're right, absolutely right. At the end of the day, it's the opposite way around. So we have null here. You are absolutely right. Thank you so much. So you are here going like that. You have 0, right? And then I have 1, and then I have 2, and then I have, yeah, it's a weird way to create it, but yeah. So basically at the end it's null, and then you have 0, 1, 2, 3. And yeah, so my arrows are wrong. The rest were good. So my arrows are wrong. This is gonna point to null, right? And then the head is 9. And you print the same way, 92, 87, 6,000. Cool, good catch. You have a point, like extra point. Let's keep going. Any questions? Anyone is not like a little confused about pointers, about stuff? No? Okay. Now we're going to talk about strings. So strings. A string is just the list of characters, right? So you only have characters in C. Does this go around? No, it doesn't go around. I'm lazy, so I don't want to. Yeah. I'm trying to do them. This one, you can draw in this, right? Yep. It looks weird. Like, cool. Strings. So here he's including a library. Strings, I think, is one of the only libraries you have in C, which allows you to, now you have more libraries, I'm just joking, which allows you to do some manipulation of strings. And in this case, this syntax is already of C++, right? std dot dot, that's namespace, and that's a C++ thing. So now we're already starting to do C++ stuff. So we're creating a string age called hello, right? And then if hello equals to age, if hello equals to, oh, this is hello. Okay, cool. There's too many hellos there. Okay, which if that's equal to h, then h equals to world. Okay, so what is this doing? Someone can tell me. Yes.
So it's creating an array of characters and storing hello into hello.
Yes.
And then it's
It's like Inception.
yeah, and then it's creating a string object called h and storing a list of characters hello into that. And then it's checking if they're the same.
Okay. Now, can you do that? So if I type this code in C, do you think it will let me do it?
I think it would probably the if statement would not be no, the if statement would throw an error because you're comparing different data types.
In reality, they're the same data type. So a C string is the same. It's not because of that. Yes.
When you create that jar array, is it just going to store h? Is it going to be able to like parse up hello, string hello?
Yeah, no, it can definitely do it. There's something more underlying here that we don't see it because we're used to being spoiled by high-level languages, like Python. Python is really easy to compare to strings. C doesn't let you compare strings like that. Yes.
Is it that you then just do H, comma, E, comma, L, like that?
No, that's fine. The namings are right. It's just this is a tricky thing, and this is a yes.
It's kind of like Java where you use like a function.
Yeah, you have to use str compare. Right. So you cannot do that. It will throw you an error. You can only use the equal signs in C for integers, floats, doubles, and characters, but not for strings. Because strings is imagine like a list. So even in Python, you can say this list equal to this list, right? Like with the equal sign. So it's just imagine it as an array. So that's the main reason why you can do it. You have to create a function which is a string compare. You put them like that. And the string compare counterintuitively will give you 0 if the strings are equals. It will return 0, and if they're not equal, it will return your number, which is of that inequality. And then yeah, so this actually will give you an error. It won't even compile, but we can try it later and see. Questions? Any questions? Yeah, so C is tricky. It's really powerful, but it's tricky. A lot of stuff that we're used to doing in C doesn't work as much. Also, I don't know, Java doesn't have pointers, does it? You don't have pointers. You can create and allocate memory with new, right? All your classes and objects, you can create them with new. But do you have pointers in Java?
You might be able to do pointers in Java if you put like an and sign after it. Is that right?
And do you use pointers in Java then? Yeah, I'm pretty sure you can call a C library language in Java too and all that, but like, do you use pointers really? So as programmers, we have kind of abstracted that. We've been like, okay, memory handling is complicated. Humans don't do it well. So we're gonna abstract it and just create languages that allow you to handle that on their own, right? That's how we've been doing it. Same with compilers, right? Before we used to write in assembly code, which is what you have been doing lately. You know, assembly code is just one operation. You have the name of the operation, the destination address, and tends to be 1 to 2 operands, right? So you want to do an addition, you do add, destination, register, and then you have 2 registers without the operands, and that makes the addition, and you have to do that. And if you want to save that into memory, then you have to do save this register into this memory, which is another register that has a memory address, right? So that's assembly. And people were like, what the hell is this? We cannot write efficient code with this. We're going to make computers compile our code into assembly. Same thing with C and Java. People were like, what the hell is this like floating point stuff that I don't understand? Let Java handle it, and I'm just going to write nice high-level code. But if you want to write viruses, if you want to write like more in-depth stuff or systems that don't really have that architecture and that high-level thing, then you do need to use C, and that's why it's still one of the most used high-level language, high-level in like that, because there's higher level languages, but C is pretty high level compared to assembly, right? So yeah, pretty much that is it. So lab 604, I don't know what that means, but it's in IDA, okay? And then I don't know what is that, but make sure you're oh, this is probably for the lab. So yeah, I got these slides today, by the way. I'm looking at them with you as I go. That's kind of cool, right? Discussion question Sunday. Oh yeah, you didn't have discussion this week. 0 for all of you for not telling the professor on time. Yeah, you told them 20 minutes before the deadline. Funny.
Still told him.
Yeah, so 0 for all of you. No,
We didn't really. We thought he gave us a break because we had an assignment due this week. We had the paper.
I don't know. Anyway, someone wants to. How much time we have left? Oh, damn, that was pretty good. I almost took the whole hour rambling around. Do you all have C compilers in your computer? Visual Studio? What do you write code in? Let me see. Let's make a quick contest. Do you have a C compiler online? C compiler online. Okay, go to this web page. Just type C compiler online. Everybody go to this web page. 3 points, you know, it's gonna be 3 points. You're gonna need it later because I'm gonna make sure that the curve, the average, the mean is 70. So half of you are gonna fail this class. Okay, everybody go there, and then I have a task for you. I want you to sort, well, let me see, you only have 10 minutes, right? 5 minutes. Really?
Actually, 4 now.
Damn it. Okay, I want you to create an array from 0 to 500 and get me the sum of all those numbers. Go. The first one that gets it, if you all get it, you get 3 points. But if not, only the ones that get it, go ahead. You'll get 3 points. No, for real, for real.
0 to 500?
Yeah. So including 500. So you have to do less than or equal to 500 or just less than 501. You don't have to include the 0 though, by the way. Because it's 0 plus 1 is just 1, right? No, I'm kidding. Anyway, go for it. Tick tock, tick tock, tick tock. You needed to make a one for loop. I do want you to play the array though.
0
Yeah.
to 500 inclusive?
Yeah, so you include the 0 and 100. But I do want you to print the array. So I want you to print the array and print the result. Oh, and the function to print, yeah. You can use printf. Because this is C. In C++ you can do cout, but we're not going to use that. Oh, and the way you format the printing of numbers, you see, you could just print the number, or you can just do, I'll show you. So you do, damn it, I think it's D, and then you pass this here. Long time I haven't number, let me see. Number equals to 5. Haven't run this in a while. Oh, you see my Pythonic ways of thinking. There you go. That's how you print the number. V is just for decimal, so it's an integer. So that's going to be how you print your result. Instead of number, that will be your result. Pretty much like Java does that, right? Formatted print. Oh. Anyone? You realize that you're gonna get a lot of errors when you first start coding in C because it's annoying. With errors for everything. And then you should be grateful for the errors because when you don't have errors, you're probably stomping in memory, which is the ugly thing about C. And it takes longer to debug when you don't have errors. Okay, don't tell me the result because. Okay, what's the result? So you have to add them together and get me the result.
Is it all 500 numbers together, or just like an array of 500? That's all we're doing.
So an array of 500, you print that, and then you print the total, the sum of all those numbers. Okay, that's perfect. Just print the array. So I think we are for that too.
We want us to print every other.
Yeah, so every element in the array and then the sum of it. Mr. Klein, right?
Yeah.
You get 5 points. In one homework or something, or maybe your exam, you know.
Sweet.
I am the one that gives points, so
Sweet.
cool. Yeah, do that. And then show me. But yeah, that's good. Yeah, that should be some. Yeah, you cannot bring the F. Yeah, you have to kind of do it the same way you did. Yes. Oh, it's pretty big. It's a pretty big number. Oh, you didn't initialize startup. You see, you just realize what happens when you don't initialize things. You are allocating memory that is garbage. So,
Yeah, okay, now.
okay, perfect. Good job.
Negative number class.
Yeah, so there was garbage in your memory, and that you will take a initialization value. That's what you need to initialize. Good. That's exactly what I wanted for you guys to kind of play with it, know what's happening. It's an easy task, but if you've done it for the first time, you'll see a lot of stuff. Okay, so James Regan, 5 more points too. Yes. Yeah, now you have to also print the array itself. The element in the array. No, you have the same problem as Mr. Regan. You have to initialize your sample. Okay. Yeah, I like it. That's good.
So hard.
Okay, so this is not
I hate any of those where I'm like,
oh, you have to remember that what I called it there. The percentage sign and the pretty much. Yes. Your result, you remember that we were talking about initializing memory? So you're allocating memory in a randomly in your memory, and it's taking that value that was before there as the result. So you should initialize if you want to push it to 0, and then you all the bits should go on. Or your order is going to be 0. Otherwise, it's just reading it random. Yes. Wait. What's your name? Mark Walls, right?
Yep. Alright. I got that one.
Is he recording your name?
Yeah.
We actually get
So Lexi, Mark. Okay.
Answer.
Say 12,000.
Okay, yeah.
12, 5, 2, 1, 2, 5.
Oh, you're reading it.
Okay, so look at Android. Yeah, it means that it has like over the
I know it was like, oh no, we should go here instead. It was just like, nah, what is it?
I didn't even need to, I just like, what's up?
Cool, guys. We're done.
Okay.
So, no, I'm sorry. Okay. I'll check these last two. Wait, you guys need to give me your names. I remember the first 5, but the last 2 I remember. That is definitely not correct. You're off by a little bit.
Wait, I plus plus. Oh, that's cool.
Yeah, I was double.
But C++ was like only invented for C++.
Yeah.
Oh,
I like
Because you're
Because I thought C++, that operator was invented in C++.
Someone, right?
Yes.
Okay. What?
it worked.
What?
Okay, you need to give me your. I'm gonna pass a paper next class. Okay, almost there. Cool. I know what's your goal? No, that's wrong.
What?
You're off by a little bit. You think close to 0 to 500. How do you get your points? Yeah. You get the points and he gets the points too because they're off by a little bit. I'm gonna get a paper right now and I'm gonna give you your names. And then I'll give you those extra 5. I'll see, but if it's an exam, maybe 3. If it's a home